BluntCut MetalWorks, May 27, 2021. Today I'm going to show you the test results of cutting 16D nail for different metal. And so the geometry of all these blades pretty much for every millimeter thickness I'm going to grind 5 millimeter tall. So in this case, this thing is 3 millimeter or something, then it will be 15 millimeter tall. I mean, not the facial, but the height, actual height. And so the primary bevel here is about 5.5 degrees per side. So all the blade in this video are going to have this geometry. And using edgepro, 600 grit diamond plate, sharpened at 18 degrees per side. It will slice phone book paper. Anyway, the heat treat, my heat treat, BluntCut MetalWorks heat treat, this version right here is heat treat 5, theta function 5,25, and the second segment is 0,50. These are my internal numbers, so you can ignore them, just say heat treat 5. Anyway, first up would be, okay, so what you see in here is a lot of dots. These are, each of these things is a nail cut. And so the nail is on, as you saw in video number 2 or 1, it cut over the aluminum plate. So, and baton on the back with a wooden hammer. Anyway, each of these is a cut of the nail right there. And so for reference, I'm going to include, this is the millimeter, I mean here the millimeters, and then the half millimeter tick mark right there, so you can see what the damage entails. And so this is a 63 Rockwell Aebl. And so now I'm going to bring in the control. Control, basically, I'm going using the mainstream or manufacturer heat treat. Basically, the popular heat treat that people use. So this is the control. Doing numerous cut also. You can see the little mark. And good cut, bad cut, because you when you cut that many times, it's about 15 cut. Some bad hit and things like that. So I mean from the it's all in toughness from the heat treat, it's okay. It passed a bunch of time, but when it have bad hit or something, or when the steel cannot handle it, and end up with really ugly chip. And so anyway, the austenite temperature for both of these blades is at, I got 2 batches anyway, one at 2100 and the other one is 1960 for these are the 1960 here, and some other alloy I use in high temperature. Anyway, so, and they go through the process, except this going to done within say 4 hours or 5 hours, because after tempering. This I done took 48 hours. So anyway, you can see the result. This is Aebl control versus BluntCut MetalWorks. And for this is N690 and this is a control right here. I have control right here. And N690 did better than Aebl, this control here. And except they also, when it fell, they have these big, also, and up with a big half moon, crescent moon chips here. So it's fairly good, actually, from just a standard heat treat instead of, my 2 days. And anyways, and BluntCut MetalWorks here, These are basically, you have compared to the worst between the two. But overall you can see it consistently and a lot of ripple. And this is N60 and 690. This is Magnacut. This is the control right here. And austenite at 2100 degrees, both of them austenite in the same bath, and it's stuck in the same oven at the same time actually, and then take it out. This one taken out after 15 minutes, and this one I think end up to about 18 minutes because I do something else, or 17 minutes. But both this thing have more consistent than 63 Rockwell, and this is 62.5 to 63.5 Rockwell. All these things, all the blades have cryogenic or liquid nitrogen soak, and so this one did not chip at all, or they have the more serious one is the edge got deflected. From previous video of this cutting, you can see that BluntCut MetalWorks, where I heat treated for a lot more impact and shock resistance. This time heat treat, I increased the yield strength and also a little higher hardness. And the outcome, you can see, is Magnacut. To control, BluntCut MetalWorks. And I will leave it here. I'm going to bring out some surprise. Previous video, I got CPM 154 at 64 Rockwell. It did really well, but it's a little bit higher ductile than I like to. Again, with this heat treat, austenite at 1960 Fahrenheit. Anyway, it's cut, I don't know, must be about 20 cut here. You can see the edge remained intact the whole way. So it did even, well, the Magnacut have a little bit more of the ductile. That means it's a little tougher here. But look at this thing. It's a 64.5 Rockwell and cut all that nail. And again, they have pretty much similar edge geometry. So yes, I would compare the same thing. That's why you have different, because the different thickness of the spine here, they have a different primary grind, and that's all. But again, the actual wedge is cut in. But in this case, thickness behind the edge is not really relevant in this one, because Aebl damage is hardly any damage, or no damage beyond even half of the sharpening bevel. So thickness behind the edge is not a play, unless you're talking about this one. Well, the damage is substantial. And I'm going to bring in, this is 26C3 a 65 Rockwell, and it did have a chip right there. It did have a chip, and but it got it get almost to about sharpening bevel height, but the rest of it are just roll and other deformation. So compared to, say, Magnacut here, it's a little bit more damaging. However, it's well, again, it didn't do as well as CPM 154 at 64.5 Rockwell. This is 1095 at 64 Rockwell, and this is a dent, a deflection, and it did better than 26C3 at 65. This is 64 Rockwell. And so the edge stability of the 1085 is actually really excellent. And so as say CPM 154 is actually the most surprise among this steel. Thanks for watching.